Good morning, everyone. It looks like we've got Sam and a few others. We have everybody muted because that's how we typically do a webinar. We're going to use the Q&A down at the bottom for any questions that you may have. So Sam, if you can just type in the Q&A, are we expecting any more people or should I get started? Okay, so all right, we got a few more people just joining in real quick. So it looks like we've got Adriana, Andrea, Kyle, Mason, Sarah, and Stephanie, as well as Sam. Sam, I'm going to unmute you. I think I just did. It won't let me unmute you.
How about Amanda? How about Amanda?
Okay, yeah, I can hear you now, Sam.
Yeah, how about Amanda? Amanda, is it on the call?
Amanda just joined.
Okay. So we should be good. I think Erica not feeling good, so I think that's everybody. Stephanie online with us as well. Stephanie Holden.
Stephanie is, yes.
Yeah. She's our VB, and we have our sales team as with us on that call. So yeah, you can start. That's good.
Okay, I'm going.
Thank you very much. Thank you very much.
Okay,
yeah.
Thanks. Okay, so welcome to this ASA ABLOY Academy training webinar specifically for your group. My name is Katie Flower, and thank you to Sam for setting this up for you. I've been with ASA ABLOY for 14 years. I did 11 years as a specification consultant. I'm out of the Dallas area. I work Texas, Oklahoma, Arkansas, and Louisiana for those markets. All types of construction projects, hospitals, schools, nursing homes, and I've done a lot of memory care as well. Prior to that, I'm from New England originally, and I was working for a door hardware distributor up there. So I've detailed doors and hardware for 35 years, and I've been with a training team for ASA ABLOY now for 3 years. So a total of 14 years with ASA ABLOY, 3 years as a training instructor, and 11 years as a specification consultant. So as I mentioned, Sam wanted me to put this together for you. What we'll do is after the first portion on codes, I will see if there's any questions. We'll do a Q&A, and then we'll get into hardware sets and schedules and how to read them. And we'll have some more Q&A at the very end. So if you've got a question, please feel free to type it into the Q&A at any point. We are recording this session, so you can look at it again if you need to refresh your memory on anything. And with that, we will get started. So the first thing we'll cover is codes. From a code perspective, there's several things that we need to understand in order to be able to apply the appropriate hardware. So codes are adopted by state, either in whole or in part. And the code that every state in the United States uses is the International Building Code. The website on the screen, www.iccsafe.org, if you type in the name of the state where your project is, it will tell you which edition of the IBC is in effect. Just because there's a newer edition, right now the 2018 version is out, but there are some states that are still under the IBC 2006. There are others under 2009. Several are still 2012. The majority are under 2015, and a handful have already adopted the 2018 edition. So the codes and standards that we will talk about today are going to be based on the International Building Code 2015 edition, but I do have a cross-reference chart, and Sam will get me, I'll either send it to Sam and he can distribute the cheat sheets to each of you, or if Sam wants to just let me know the emails, I can send it to the group. Either way. A standard is something that's referenced by the code. And we have many standards in our industry. NFPA 80, for example, is the standard for fire doors and hardware. And when we're working on projects, you need to understand which doors are fire rated and what you can and can't do. We're not going to get into full depth on that today. But by reference, the standard is referenced by the code. And again, whatever version the year that is referenced is the one that's in force for the area, for the project that you're doing. So a standard is a set of criteria by which everything else is measured or compared. If you need a fire door, it needs to look like this and act like this and be like this. The code itself will tell you where you need fire doors and what ratings they need to be. That's how they work. So same thing with ADA, the Americans with Disabilities Act. The standard that makes the ADA requirements accessible is ANSI A117.1. And that's referenced also in the International Building Code. And by reference, it becomes part of the code. NFPA 101, just by the way, is not a building code. It is a life safety code. You'll probably hear NFPA 101 a lot in the day-to-day projects that you work on. If you have two codes in effect, the IBC and NFPA 101, and there's any kind of conflict in requirements between the two, you are supposed to go with the more restrictive requirements. And sometimes you may have to compare the two to find out what that is. Sometimes you may have an architect or a contractor that can tell you, but when in doubt, you do need to look it up rather than make assumptions. These are comparisons that I have created, and I will send these to you after, but it goes through the different code versions, IBC 2006 through IBC 2018, and where the specific code reference is, as well as NFPA 101, 2006 through 2015. As you can see with controlled egress, we can only use that in two types of occupancies. And the occupancies that can use it happens to be one of the ones we'll be talking about today, Group I1, assisted living. And those are going to be your senior memory care, where you have custodial care for the people that are living there. And it has started in IBC 2015 as well as 2018. So if you have a project that is under IBC 2012, you cannot use controlled egress. If you have a project that's IBC 2015, you can. NFPA 101 has allowed it since 2006. You may have, you'll hear me say AHJ, the authority having jurisdiction. You may have a fire marshal or local AHJ that will allow it, even though IBC doesn't, and that's okay. They have to grant a variance. They have to say that it's okay in writing for you to do that. Group I2 is healthcare, which would be your hospitals and nursing homes. And I don't believe you do any nursing homes. Assisted living would be your senior custodial care type housing. Then I took the requirements for controlled egress and the different code versions and what is or is not required. So for example, in IBC 2015, yes, all clinical staff need to carry a key or credential. The approved procedures must be posted. And we'll get into these requirements in just a minute. But these cross-reference sheets are nice at a glance. They can tell you, they can show you where exactly, what year the code changed and where the references are so that you can look them up. Delayed egress. Delayed egress has a lot more use, the different types of occupancies that can use it. The only ones that can't are Group A, assembly, Group E, educational, and Group H, high hazard. So unless you have an assisted living facility that has assembly mixed in, for example, the dining area, If there's a dining area and you have more than 50 people, you cannot use delayed egress. If you have group I1 assisted living, which is the 5th column over, you can use delayed egress virtually everywhere with as long as you follow the requirements in the code. And group R residential, I point this one out because assisted living could be a residential occupancy. And I will explain that in just a moment. There's 2 different ways we can classify assisted living facilities. And it's very critical that you know for your project area which one it falls under. It changes dramatically what you can and can't use for hardware. So after comparing the different occupancy types by code, I also have a cross-reference of the requirements for delayed egress. And they're very similar, as you can see. The code references might change slightly, but it gives you a chance to know exactly where to go to look it up and a snapshot of the different code versions, what is or isn't required. Means of egress, I want to make sure that we are on the same page, because where you put controlled egress and where you put delayed egress matters, because in some cases you can only have one in a path of egress. So what is a path of egress? It is a continuous and unobstructed path of vertical and horizontal egress travel from any occupied portion of a building or structure to a public way. And a public way is just safety. A means of egress consists of 3 separate and distinct parts: the exit access, the exit, and the exit discharge. We do have many exit access doors within a project. Most of the doors in a building are exit access doors. They lead you to an exit. And so because of that, we have to treat exits and exit access doors the same when it comes to hardware, but it's important to understand the distinguishing difference. The exit access is that portion of a means of egress that leads from any occupied portion of a building to a structure to an exit. So all the area shaded in gray is that exit access. If I am here in the multi-purpose room, this is exit access. This would be an exit access doorway. And I get out to the corridor. I have the choice now between 2 separate exits. I can go left to this exit stair or take a right and go to this exit stair. I'm probably going to go to the closest one unless I smell smoke or see fire heading in this direction. So you go out, exit access. All of the doors on this floor would be exit access doors, except for the ones going into the stairs, and those are actually the exit. The exit is that portion of a means of egress system between the exit access and the exit discharge or public way. Exit components include exterior exit doors, which many of us think of when we think of an exit. We think of the exterior exit doors. Those are indeed an exit, but also interior exit stairways are an exit. Exit ramps, exit passageways, exterior exit stairways and ramps, and horizontal exits. So once we get into the stair, we are now separated from the rest of the building. We have fire protected openings and fire resistance rated walls, floors, and ceilings. In a high-rise building 4 stories and higher, we have 2 hours of protection and 90-minute B-label fire doors protecting the stairs. If it's 3 stories or less, it's 1 hour fire rating and 1 hour protection for the door. A horizontal exit, if we have a very large building, the maximum size of our fire compartments or smoke compartments is 22,500 square feet. And therefore you'll see a horizontal fire barrier that separates this part of the building from this part of the building. So if the fire starts in this fire compartment, once I cross through this double egress door, I'm now not in the compartment of the fire origin, and I am protected by 2 hour fire barriers for 4 stories and higher, or 1 hour fire barrier if it's 3 stories and less. So these double egress doors become an actual horizontal exit. Once I get through this door, I'm still on the same level, but I could either wait for someone to rescue me. I'm in what's called an area of refuge, or I can continue my path of exit travel, get to a vertical exit stair, and down the stairs and out of the building. So horizontal exits, you'll see those in memory care and assisted living facilities all the time. Not all of them are horizontal exits, however. They have to be B-labeled fire doors in order to be an exit. Other than that, it's an exit access or a smoke barrier, and those are completely different. They're still in our means of egress, though. Okay, so different types of occupancies. I mentioned institutional group I. It's defined in the building code in chapter 3. What you will be most using would be the I1 assisted living facility. And the difference here is because it's institutional, this is where patients have 24-hour supervised environment and receive custodial care. And because of that, people are not capable of self-preservation. In the middle of the night, if there was a fire and people had to evacuate the building, these people are not capable of getting out of bed and walking to the exits by themselves. They're going to need some help from the clinical staff. And that's why we have areas of refuge where they may move the patient while they're still in their bed. And that's why we see wider doors in assisted living facilities that are custodial care, as well as healthcare facilities, your hospitals and nursing homes. So I know you do a lot of different assisted living facilities. If it's custodial care, then it falls under the I1 classification or designation. The residential group R is assisted living facilities are group R4. They are supervised facilities, but the patients are capable of self-preservation and they don't have to rely on staff to evacuate them in a fire or other emergency. In R4 occupancies, these are independent living facilities. The occupants can exit the building, as I mentioned, without assistance. The hardware requirements and the permissions for this type of occupancy are vastly different. And again, I just want to make sure that you understand the difference between institutional I1 assisted living, where the clinical staff will be helping patients or helping people move through the building. You can also have mixed use. Within the building, there may be some assembly portions of the building. Your dining room, if there's more than 50 people in the dining room, then exit devices would be required for those doors because it's group A assembly. So in assisted living, you may have a swimming pool area or a gym. It all depends on the occupant load. If in that area of assembly, a multi-purpose room, that you could have 50 or more people, then you need to put exit devices. Would active adult fall in R4 category also? I would imagine so. Just the word active. If you want to send me any more of a definition, my email address is at the end. I'd be happy to help you. But I would assume that yes, that it would be under R4. Okay, so locking the door on the egress side. Unless by specific permission, we are supposed to have free egress, one motion free egress from the egress side, unless by exception. So in 1010.1.9.3, and this is IBC 2015, locks and latches shall be permitted to prevent operation of doors where any of the following exist. 1, places of detention or restraint. This is typically talking about mechanical locking hardware on the egress side. And this is left wide open so that the AHJ can assess the risk based on the number of occupants and the type of facility, the type of structure. Is it a wood frame structure or is it steel stud? Is it concrete walls? Do they have fully sprinkler? They will assess the risk based on all of those factors and then determine whether or not you can lock the door on the egress side. And again, this is from a mechanical standpoint. There are 4 special locking arrangements that the code recognizes, and that's where controlled egress and delayed egress fall into. So those, unless by specific permission, we can't lock the door on the egress side. Controlled egress, we are actually locking the door on the egress side with a mag lock. This is a typical cross-corridor pair of doors, and this is actually in a hospital. It could very easily be assisted living, but the card reader will release the mag lock from the egress side and allow me to exit. If I'm not authorized, then depending on where this is in the building, it probably needs to be tied into the fire alarm to release so that at the time of fire, I can exit the door. These have very limited use. We can only use them in group I1, which is our assisted living facility, which would be your senior and memory care type, where the patients are receiving care, and I2 are your hospitals and nursing homes. And this is IBC 2015 and beyond. It's in NFPA 101 in all of the different versions, but if you've got a project that uses IBC 2012 or 2009, then out of the box, you can't use controlled egress unless you get specific permission from the local authority. But what this is electric locking systems, including electromechanical locking systems. They shall be permitted to be locked in the means of egress in assisted living and hospitals where the clinical needs of persons receiving care require their containment. So memory care, we want to contain the patients. For their best interest, we do not want them wandering outside that particular door. That's where the wander care comes in, the wander guard comes in. If you get too close to that exit, the door should lock because of your sensor. They've got the band on either their wrist or wherever. And when the patient gets too close, a patient that's high risk for flight, that would lock the door. So the door could start already locked, or it could be unlocked, and with the wander guard, when a patient is within the range of the reader, it locks the door and they can't get out. That's the most common use for this. Controlled egress doors shall be permitted in such occupancies where the building is equipped with automatic sprinkler system or an automatic smoke or heat detection system. And all of the following criteria need to exist. Number 1, the doors unlock on the actuation of the automatic sprinkler system or automatic fire detection system. A lot of people misinterpret this. This does not mean a pull station. A manual pull station is not the same thing. Many times when you have an exit door, within the exit door distance, you have the little red pull fire alarm pull station. That will sound the fire alarm, but that isn't actuation of the fire alarm system. The fire detection system must smell smoke, or the sprinkler system must have water flowing through it in order to actuate and unlock this door. Just the manual pull station itself does not unlock this door. And that's a safety thing, that's a security thing, because years ago in Alzheimer's and memory care, the patients got smart and figured out all I got to do is pull on that little fire alarm and it's going to unlock the door and let me out. And so the codes started to say, okay, well, we really don't need it to unlock on manual pull station. Where we really need it to unlock is when there's some kind of smoke or some kind of actuation, the water is flowing through the sprinkler system, that will make it unlock. 2, the doors shall unlock on loss of power controlling the lock or lock mechanism. That means that the lock has to be fail-safe. A fail-safe lock has to have power in order to stay locked, and a mag lock especially, the only way it can create that magnetic field is to have the power. The electricity excites the copper coil, that creates a magnetic field and holds with whatever holding force that the mag lock is rated for. 3, the door locking system shall be installed to have the capability of being unlocked by a switch located at the fire command center, a nurse's station, or other approved location. The switch shall directly break power to the lock. Because it's electrified, any switch can be wired to unlock remotely, whatever the distance away. So this really is very easy to achieve. And you may or may not be the one that is supplying all of those different switches, but just be aware that it is a requirement. 4, a building occupant shall not be required to pass through more than one door equipped with a controlled egress locking system before entering an exit. That's why I went through the definitions. When we look at our life safety plan and you look at the location of controlled egress and your location of your exit, you're not allowed to have more than one in a path of egress before entering that exit. Procedures for unlocking the door shall be described as and approved as part of an emergency planning and preparedness as required by Chapter 4 of the International Fire Code. And 6, all clinical staff shall have the keys, codes, or other means necessary to operate the locking system. So if this door starts in a locked position or not, the card reader, all staff must carry the credentials in order to unlock this door on the egress side. Emergency lighting shall be provided at the door, and the door locking system unit shall be listed in accordance with UL 294. And as you can see, this is from Securitron. These are all the various listings. UL 10C is for fire. UL 294 is an access control code or standard, sorry. And there are a couple of exceptions which will not pertain to you. Items 1 through 4 shall not apply to areas of behavioral health or psychiatric treatment area. And items 1 through 4 shall not apply to infant protection systems. There is no group of exceptions for memory care. Maybe someday they'll add it, but out of the box, you have to meet all of the requirements for controlled egress, and you are not exempt from items 1 through 4. So the most common applications of where controlled egress would be used would be behavioral health areas, dementia units, memory care units, infant patient wings, maternity wings, etc. And the type of hardware that you would use, the types of components, you're going to have a mag lock most of the time. It's fail-safe by nature, or you could use a fail-safe electromechanical lock, either a cylindrical or mortise lock that is locked on the egress side, and only by exception could you use fail secure, and that's for behavioral health or infant protection. It does not apply to your types of projects. Securitron makes a whole line of mag locks from 600 pounds to 1,200 pounds holding force, or 1,800 pounds of holding force. They make other types, and typically with memory care, you're somewhere in the 1,200 pound range. Delayed egress is the second special locking arrangement. This one is going to sound an alarm. I think everybody's familiar with what delayed egress is. Let's look at our requirements. As I mentioned before with the cross-reference chart, delayed egress is used in more applications than controlled egress. This does lock the door on the egress side, and it can be used anywhere except for Group A, which is assembly, Group E is educational, K through 12, and Group H is high hazard. So the only place in your building that you need to look at is if you have some Group A intermingled with your I1 assisted living senior memory care. That dining area, if you have a dining hall that has more than 50 people, that's Group A assembly, and you can't use delayed egress or controlled egress from those spaces. And that can get a little bit tricky. They either need to separate the dining area completely so it has its own exits directly to the outside, or they need to come up with some other way. But buildings that have an automatic sprinkler system or a smoke detection system installed, and all of the following criteria for delayed egress. Number one, your delay electronics shall deactivate upon actuation of the automatic sprinkler system or automatic fire detection system, allowing immediate free egress. Once again, the pull station, the manual pull station is not what this is talking about. The manual pull station will not unlock a delayed egress lock. It has to have either water in the pipes moving in the sprinkler system or smoke detected by the fire detection system in order to activate and unlock these doors immediately. The delay electronics, the locking system shall deactivate upon loss of power controlling the lock or lock mechanism, allowing immediate free egress. This means, once again, that it needs to be fail-safe. 3, the delay egress locking system shall have the capability of being deactivated at the fire command center or other approved locations. That's merely a switch, and that the fire command center is usually on the first level by the main entrance. So that's where the fire chief would come in and start looking at the layout, the floor plan, where everything is, and turn things off or unlock doors that they need to, all right there. So switch can be located anywhere. You may or may not be the one actually supplying it. 4, an attempt to egress shall initiate an irreversible process that shall allow such egress in not more than 15 seconds when a physical effort to exit is applied to the egress side door hardware for not more than 3 seconds. There is a nuisance delay that's built in. If little Johnny is visiting his grandma and he can't read the sign that says push, there's a loud alarm, and his mom pulls him back away after he pushes on that exit device or pushes on the door, long as she pulls him away before that nuisance delay, it will not set off the alarm. But initiation of an irreversible process shall activate an audible signal, very loud alarm in the vicinity of the door. Once the delay electronics have been deactivated, rearming the delay electronics shall be by manual means only. That means that somebody from the assisted living facility needs to come to the door, check it out, what happened, what set this off, and rearm at the door. Most delayed egress systems have a built-in key switch. It can be a key switch, it could be a card reader, it could be any kind of other than just a push button switch that anybody can reset. It's got to be something that carries a credential in order to rearm the delayed egress. And there is an exception for where you can have 30 seconds, but that typically does not apply to memory care units unless you talk to the local AHJ and get it approved. That's typically reserved for behavioral health. The egress path from any point shall not pass through more than one delayed egress locking system, with the exception of hospitals and detention facilities and detention correctional facilities, that type. The egress path may have no more than 2 delayed egress with a combined total not exceeding 30 seconds. So if we have a pair of double egress doors here and we have delayed egress here, we can't have delayed egress on the stair door as well, because that's the same path of egress. And if we were using delayed egress as part of the wander guard, this would be armed. I suppose it doesn't have to be armed. It could arm once somebody is within range of the sensor. And again, the sensor is nothing more than a switch. So the switch from the wander guard system can either lock the door, or if it is locked, just make sure that it can't be unlocked at the time when somebody is within range of that door opening. And the whole point of WanderGuard, at least the one that Stanley makes, I haven't seen all of the other ones, and I know you work with several different types, but because of the Bluetooth signal, when they're within range of that door, the whole purpose is that somebody can come and get that patient before they sound the alarm, before they hit the delayed egress door and actually then disturb other people in the area. So that hopefully it will save them from reactivating or rearming the delayed egress at the opening. A sign needs to be provided. Most of your hardware comes with a sign that says push until alarm sounds, door can be open in 15 seconds. Emergency lighting provided on the egress side of the door, and delayed egress locking system in accordance with UL 294. The most common applications: the side or back door of a business, the side or back door of a store, doors in hospitals to restrict public access. And from your perspective, you can use these either in I1 or R4, senior living and memory care, to restrict the wandering elderly patients. Types of hardware that can be used: Securitron makes a delayed egress mag lock that has everything built in. It has the key switch to reset built right into the unit. These are great if you have an existing door with existing mechanical hardware. You just have to get wire to this and tie it into the system however you need to. If it's new construction and you don't need an exit device, you could use this with a cylindrical lock or a mortise lock. Depending on the type of door that they have, how wide is the style will dictate the type of hardware that you should kind of lean toward. You can also get exit devices with a full built-in delayed egress. Sargent makes them, Corbin Russwin, Yale. I will be, at Sam's request, I will be making some generic hardware sets specific to both controlled egress and delayed egress, so that you've got the list of components. What normally goes into this type of opening, whether it's an exterior door, a stairwell door. We'll talk about stairwell reentry here in just a minute. And then maybe even some other typical interior doors. But to start off with, I will be creating hardware sets typical for exterior doors and stairwell doors that you will normally be supplying these components. There needs to be some kind of key switch or manual reset that takes a credential. It could be a card reader even. You may need a touch sense bar to initiate the delay, depending on the type of unit that is selected. And just once again, to refresh your memory, controlled egress can only be used on I1 assisted living, 2015 and 2018 IBC. Anything prior to that, you need a written variance from your local authority having jurisdiction. NFPA 101, it's been in there for years. So you may be able to get permission fairly easily, since it is something that's been out there for quite a long time. You may not have too hard of a time getting approval for it. Delayed egress is used in both the I1 assisted living or the R4 assisted living. You can use it on either. Just remember the rules: no more than one in a path of egress. Here's a little floor plan with some doors. It's a 2-story senior living memory care, fully automatic sprinkler system. It is custodial care. The owner wants to lock 3 units from the dementia wing to prevent patients from wandering out. If we look at the expanded plan, these are the 3 doors that they want to have some kind of locking with the WanderGuard. So the question is, and just think to yourself, what is the occupancy type of this building? And what code compliant hardware best meets the owner's requirements? Let's go back to the first slide again. It's a 2-story senior living memory care with custodial care. And we want to lock those 3 doors here, here, and here. So if a patient gets up and they're wandering and they're within this door, the wander guard would lock the door. How would we do that? What is the occupancy type and what code compliant hardware? I'll just give you a minute to think about that for yourself. And the answer is, it is group I1 assisted living because it is custodial care. And because of that, if we're going by IBC 2015, which this presentation has been, that means that we could use either controlled egress or delayed egress. And the nice thing is, these doors are all three separate paths of exit. So this is one exit. Here's a different path to that exit. And this may be an exit access to get to this door. It doesn't at this point really matter because it's a different way from the other two. So we could lock all three of these doors to keep this wing secure from the other. And whether, as I mentioned, whether you use a mag lock for the controlled egress and it only locks when the patient is picked up on the sensor, or delayed egress where it's always locked and when they're within range of the sensor, it sends staff and they go get them before hopefully they sound the alarm. And the last thing I want to talk about code-wise before we get into the hardware is stairwell reentry. What is it and why is it? When we think of stairs, a stair is an exit. It gets us out of the building. And we're protected once we get into the stair with fire barriers that are either 2-hour rated or 1-hour rated, depending on the height of our building. The longer that we're going to be spending in that exit, in that vertical stair, the more protection we need. So 4 stories and up, high-rise buildings, 4 stories and up, 2-hour fire rating, and 3 stories or less, 1-hour fire protection rating. But once you get into the stair, you should be home free. The stair is going to take you down to the level of exit discharge. The door at the bottom of the stairs gets us out of the building and free and safe. But what if you get into the stair and as you're exiting, you smell smoke? Now, typically, there's nothing flammable in stairs. They keep the stairs clear of any obstruction. There shouldn't be any boxes or any flammable materials sitting in the middle of the stairs. But we do know it's a changing world and people are flying airplanes into buildings and therefore taking stairs and making them basically a chimney. Or this was an actual fire in 2003 at the Cook office building in Chicago. It was a 38-story building. The fire started on the 12th floor in a storage area near the stair. The stair door was opened from the fire department when they came up to check it out, and the black smoke that was in the corridor, because the storage area was right next to the stair, the smoke started flowing into the stairwell. And people that were exiting smelled the smoke. Smoke is a leading cause of death in a fire. They smelled the smoke, so they started to go back upstairs trying to find another way to get out of this burning building, or at least out of the, now it's a chimney, you've got smoke that's rising coming up after you. And every door was locked on the stair side. They could not get back into the building, and 6 people perished because they couldn't breathe. They finally succumbed to the smoke inhalations. Several people were finally on the 27th. They had to go, they were basically close to the 12th level when they smelled the smoke. They had to climb back up to the 27th level before they could finally get back in. And that's just not the way that it should be. The codes in place at the time, every place else in the United States required stairwell reentry. I don't know why they weren't in that particular place, but they weren't required, and now they are. So that's the good news. So the purpose of stairwell reentry is for 2 things. 1, if you need to re-enter the building and find another exit, and two, to allow the firemen access to all the different floors very quickly without having to fiddle with the key that they got from the Knox box. If we look at the terminology, I just want to make sure that we're all on the same page. On a cylindrical or a mortise lock or an exit device trim, when we talk about fail safe, on loss of power, the outside handle is unlocked. We have free egress from the inside at all times. So you can enter the stair with free egress, and it's locked on the stair side unless the fire alarm releases, and then it's unlocked. Fail safe is unlocked at the time of fire. Fail secure on loss of power, the outside handle is locked, and you have free egress from the inside at all times. That's different though when we think about an electric strike. With an electric strike on fail safe, this keeper would be not locking, and therefore, because it's basically an open door, the pressure of a fire could push that door open, and a fail safe electric strike does not provide positive latching. Fail secure for an electric strike on loss of power, the keeper is rigid and does provide locking and positive latching. So this would not allow re-entry for stairwell purposes. So when we think of stairwell re-entry, electric strikes are not permitted. In order to have re-entry, we'd have to make them fail safe, but that doesn't provide positive latching, and 99.9% of the time, they're going to be fire rated doors. They have to have positive latching. And then mag locks do not provide positive latching. They are fail safe and fail safe only. They are unlocked on loss of power. They must meet special locking arrangements. So if you're going to use a mag lock going into a stair on a memory care unit, whatever the case may be, you have to have some other type of latching hardware, either a mortise lock, a cylindrical lock, or a exit device. It will be passage on the stair side, so the mag lock locks the door. On fire, it would drop, and you could get in or out of this exit door. IBC, low rise versus high rise. Low rise stairway doors need to comply with Chapter 10 of the IBC. High rise stairway doors, the hardware is exactly the same. There's one additional requirement that doesn't affect what we supply or what you would be supplying, but high rise stairway doors are covered in Chapter 4 under the special use and occupancy type. But the difference is when you have 75 feet or higher above the lowest level of fire department vehicle access, that's considered high rise. So if a fire truck can park on this level, their ladders are 100 feet long, but you can't put the ladder straight up 100 feet in the air. There's no way to carry your oxygen and everything that you need to carry. So you have to have an angle to the building, and that gives you an effective 75 feet of where you could climb the ladder and reach a window. That's where the definition is, 75 feet above the lowest level of fire department vehicle access. But again, the hardware requirements are exactly the same on whether it's low rise or high rise for the door. So here it is from Chapter 10, the low rise requirements. Interior stairway means of egress doors shall be openable from both sides without the use of key or special knowledge or effort. This is the only place in the building code that tells us we have to unlock the door on the ingress side coming in. It does not apply to the ingress side of the exit discharge door. Once you leave this stair and you're outside the building, you do not have to come back in. And if you do need to come back in, you've got to go back around to the front entrance. So this is not meant to leave the building unsecure. The door at the bottom of the stairs going out does not apply to this requirement. And it says it does not apply to high-rise doors arranged in accordance with 403.5.3. They have their own special rules, but hardware-wise, exactly the same. 3, the doors are permitted to be locked from the ingress side, provided that they're openable from the egress side and capable of being unlocked simultaneously without unlatching upon a signal from the fire command center, if present, or by a signal from the emergency personnel inside the main entrance to the building. So all of our stair tower doors from the stair side can be locked, but they have to be locked with a fail-safe locking that will unlock on the fire command center or on fire alarm, depending on where they want it unlocked and under any conditions. So it's got to be fail safe. So if the power is out, you can re-enter and find another exit. The only additional extra thing you need in a high-rise building is every 5th level, there needs to be a 2-way communication system installed. I don't believe this is part of your package, but if it is, it's not a piece of hardware, it's just a panel that goes on the wall every 5th level, so that if somebody needs to get in, somebody at the fire command center can push a button and remotely let them back in. Hardware-wise, it's exactly the same thing. The door needs to be capable of unlocking simultaneously without unlatching by a signal from the fire command center. What type of hardware is code compliant? Fail-safe electromechanical, cylindrical, or mortise locks. They're fail-safe, so free egress to get into the stair, and at the time of fire, they would simultaneously unlock and allow re-entry. Exit device trim that is fail-safe would comply. You could have a passage mortise or a passage cylindrical with a mag lock. The mag lock is fail-safe. As long as it meets all the requirements for controlled egress, you would be fine to have the mag lock on a fire-rated door as long as it's got a latching device and a closing device with it. You could also have delayed egress, where your exit device has passage trim and you've got the built-in delayed egress system, or delayed egress exit device with fail-safe trim on the other side. Either of those meeting all the requirements for delayed egress would be okay. And sometimes those stairs, you want to prevent the patients, the elderly, from wandering into the stairs so that they can't get out of the building. Hardware that's not permitted. I don't know why that. Anyway, that's sideways, sorry about that. Fail secure electromechanical or cylindrical or mortise locks, fail secure electromechanical exit device trim. They're not permitted because if the power goes out, fail secure, there's no way to unlock them simultaneously. Same thing with exit device with electric latch retraction. In order to remain positive latched, it needs to be in the latch position, but then you can't have re-entry at that point. And same thing with fail-safe or fail-secure electric strikes. You can't use those. As I mentioned earlier, fail-safe would allow re-entry, but doesn't give you positive latching, and fail-secure gives you positive latching, but it doesn't give you, in electric strike, it doesn't give you the re-entry. Now let's get into hardware schedules. What are they? What's a door schedule? Where do you find the information that you need as far as manufacturers and different things like that? So hardware schedules follow DHI's hardware sequence. DHI is the Door Hardware Institute, and they have created a standardized sequence for hardware that basically follows the installation track. What's the first thing that you would do? Well, the first thing you would do is hang the door. So selecting the hinges or hanging the door would be the first item, and then securing the door, what type of lock or latch, control the door. Do we have a closer, some type of control device, maybe a power operator, and then protect the door. That's all the accessory things like kick plates and wall stops, weather stripping, thresholds, and those kinds of things. So the format, when you look at a hardware set, is always going to be in this same sequence. If it's a pair of doors, the inactive leaf is secured first. So you hang the door, and then it should be the inactive leaf, then the active leaf, and then same thing for control the door, inactive leaf, then active leaf, etc. Let's take a look at a sample hardware set. It gives us the quantity of hinges, the lock, the closer, etc. The door numbers would be listed in the hardware set, or you could have the set number in the door schedule on the floor plans. Sometimes you'll find the door numbers in both places, and hopefully that does not create a conflict. The size and type of room, that description may be in the hardware set. You may get that information from the floor plan, from the door schedule. The size of the door, the material of the door, that may be in the hardware set. It is in a detailed hardware set, but a specification set may or may not have this information. It depends on the spec writer and the architect, but it's always going to be in that same order: hang the door, secure the door, control the door, and then what type of protection, protect the door. We'll look at the first item, the hinges. A lot of times the architect on submittal will get a cut sheet to go with, so that you can see the specifications of the manufacturer, the base metal, all of that information. The privacy lock itself, what are the functionalities, extra accessories that may come with that, different options for thicknesses of the door, things like that. Door closer, when you're detailing the closer, the specific arm that comes with it, whether the door swings in or out, kick plate, the size, the specification set will say that it's 2 inches less door width. When you're detailing it, you would put it down as the actual size based on 2 inches less than the door width. The door stop, type of anchoring, what do you need to order that? Make sure you get the right material. And then in this case, silencers, could be smoke seal. You could see weather stripping here. And if it were an electrified hardware set, at the very bottom, you would have an operations narrative. I do have some examples of those. We'll talk about why they're so very important. And then all together, here is the door that we just talked about. You can see it's got the standard hinges. It's got a mortise privacy set. It's got a door closer on it, a wall stop. And when I'm in the restroom, it's got a thumb turn on the inside so that I can lock the door. And then one motion, turn the lever, will retract and let me out. So that's common sequence for hardware sets themselves. Where do we find the hardware sets? Where do we find the hardware schedule? In the construction documents. Construction documents are both plans and specifications. And the adoring term for specifications, we call them specs. They're not just what you put on your face anymore. So construction documents, they have your quantities and qualities of materials for a construction project. If it's new construction, it also talks about the relationships between all the suppliers. It's contractual obligations between the project owner and the contractor, and the roles of the construction team members as well. For the plans themselves, the construction plans are typically going to have a series that are architectural, interior, electrical. They're not all combined into one big set of drawings. They're separate drawings. And so for the purposes, you may need to look at the architectural drawings in addition to the electrical drawings if there's all kinds of access control. Where is the wander guard? What are some of the requirements? There's also life safety plans you may want to take a look at to see, is it classified as an I1, or does the architect have this listed as an R4 type assisted living? And then the other component is the spec book. The spec book is a written project manual. It has your products, your materials, and methods for installation. Floor plans are a representation as if you were cutting the building and then looking straight down. You're taking the roof off of it, you're cutting through all the walls, and you're looking straight down on top of it. It shows us our path of egress. It shows us our door openings and our exit stairs. It shows us all the different rooms and where may be the security breaches or the security points that we're looking at. You can also have elevations. They show you, it's as if you're taking a snapshot and looking at the wall vertically. You see doors, you see windows, you see trim, you see anything that may conflict with, if you've got a wander guard sensor, do you put it here? Do you put it here? Where would it go? Your elevation can help you with those kind of things. We also have, in the architectural drawings, we have door schedules. And I know you can't read this. I'm not expecting you to read this. I do have coming up kind of a blow up of it. But on the door schedule, you can get your size of your doors. You can get the type of materials. You can see the elevations, and do you have style width for the different hardware. You can look at your frame, and do you have room to run the wires through the frame to get it to the lock and the locking system? What type of head? Do you have a 1-inch head face or a 4-inch head face? Do you need to be aware of those kind of details? And then the specifications, CSI, the Construction Specification Institute, has a master format. So it's a standard method, no matter what project that you're working on in North America. Every architectural firm has all 48 specification divisions organized in the same fashion, so that you can always find the information you're looking for. Your different divisions, the different divisions that have an impact on our industry. Division 1, the general requirements for the bid date and warranties and anything that project closeout, anything that applies to every specification section in the book. Division 08 is openings. That's our stuff: doors, frames, hardware. Our electromechanical hardware may need to tie into the access control. That's going to be Division 28. Who supplies the card readers? Who supplies the wander guard? Where is it tied into the electrical and fire alarm and those kinds of things? So if we look at the breakdown of a division, the section numbering 087100, that's door hardware. That's our stuff. The first 2 digits, 08, represent the division number. So we know that Division 8 is openings. Door hardware belongs on door openings. So it starts with the 08. The next 2 digits, 71, are the subgroup, which is level 2. And then the third 2 digits represent level 3, which can expand into additional spec sections. So for example, 087100 is your door hardware. 087113 specifically just automatic door operators. Sometimes you'll have items of hardware that are special enough that they have their own section. Specifications are broken into 3 parts. And again, so that it doesn't matter which architect you're working with, part 1 is always going to be general to that specific section. Part 2 is your products, your manufacturers, who is accepted, how do you have substitution requests, things like that. And part 3 is execution. Execution meaning material handling and keeping things protected while construction is going on, installation, things like that, and even product testing after you have something in the field. Testing and training would be in part 3, execution. Here's a sample chapter 1. It's in summary form, outline form. So if an architect doesn't use any particular item, they just skip it and it stays with the same format. 101, summary, the section includes. It's important to look at what is included in the section, because you may have a completely different spec section that has certain components. And if you want to make sure you're bidding apples to apples and comparing apples to apples, make sure that it's included in that section or not. And then wiring diagrams, templates, keying schedules, quality assurance for the supplier, the installer, things like that, delivery, storage, and handling. You'll see that, again, part 1 is general to the entire section. Part 2 is where you're going to find the majority of what you're looking for. Who are the acceptable manufacturers? Sargent, Corbin Russwin, Yale, Securitron, HES. We're looking for things like that. What is the process for substitutions? Sometimes you have to have 2 weeks before the project is due for bid. You have to have substitutions to the architect through the contractor. We can't just send them directly to the architect. There is a procedure involved getting them to the contractor who's bidding the project, and then getting them from there to the architect for review. If a substitution is accepted, it will be issued via addendum so that all bidders will have the opportunity to see what has changed and what is now also approved. All of your different products, the specific products, are listed here in part 2. And then in part 3, it includes your installation information, mounting heights, clearances, any kind of field quality control. And the final thing of part 3 is the hardware sets. That's where you're going to find the pre-built hardware sets, hopefully with a good description of operation when it comes to any electrified hardware components. And so hardware sets, they're going to be in numerical order. Some will be numbered 1 through 100 or whatever. Some spec writers use a 6-digit numbering system, but they will be in numerical order. The spec hardware set may be something as generic and simple as just telling you the items, and then you have to look in part 2 product to determine what specific items will be used. And sometimes they will list the quantities and the actual item with all of the details for you to price out exactly what it is that you need. Sometimes they'll give you a combination of both. They won't put the sizes on here, but they will give you the model number and items enough so that you can then figure out the pricing and sizes based on your takeoff and the floor plan. So for electrified hardware, I mentioned that we need an operations narrative. It should go at the very bottom of the hardware set. And the reason that we have an operations narrative, the reason that it is so critical, is because electrified hardware can be wired in any number of different ways. As compared to a classroom function lock set. A classroom function lock set is described in ANSI BHMA, and it's only one way every time, no matter who makes it, whether it's a Sargent, a Corbin Russwin, a Schlage, any manufacturer's classroom function lock set is going to be key outside, locks and unlocks the outside handle, free egress from the inside at all times. That description is in every manufacturer's catalog, but it's based on the standardization by ANSI BHMA. There is no standard for electrified hardware. We can have an electric strike and 2 different push buttons, but that doesn't tell us how that door is going to be used. And if we don't know how the door is going to be used, we certainly can't do wiring diagrams and we can't wire it appropriately. But especially when you're dealing with more complicated openings like delayed egress or controlled egress, where you've got the wander guard, when is that door locked? Is the door always locked? So that's number 1. What is the opening at rest? What state is the opening in? The door is closed, latched, and unsecure, or the door is closed, latched, and secure. What state does it start off with at rest? The second item is, how is the outside operation? How is ingress granted electrically? Is there a card reader? Is there a keypad? What is the electrical ingress? Or is it just a remote release from a nurse's station or from any location, wherever that may be? And how is ingress granted mechanically? Many times when we have electrified hardware, we have a key override. so that if the power goes out and if it's a fail secure lock, we can still get in with a key mechanically. So you may or may not have key override, and if you don't, then you wouldn't have that listed. The third item, what happens on power failure? We talk about fail safe versus fail secure. Does the item stay in the lock position and still grant free egress, or is it fail safe and will be unlocked at the time of fire? If there is fire alarm, what happens on fire alarm? Is the power dropped immediately, or is there a 5-minute delay before it's unlocked? What specifically happens on power failure? Fourth, if there's LEDs, what does the LED indicate? Red is locked, green is unlocked. Those are pretty common. You may or may not even have LEDs. You can skip this from the operations narrative if it doesn't apply. And the fifth is inside operation. The fire marshal, the AHJ, is going to be very curious as far as what happens here. If the inside is free for egress all times, no problem, they'll move on. But if there's a delay of egress, what happens and what makes it code compliant will be listed here. Is it controlled egress? And again, if it is, then there would be a little bit longer description here of what happens on the inside. With a patient that's wandering near the opening, they're picked up on the wander guard system, which locks the door immediately, and the door remains locked until the patient's far enough away from the sensor. Something to that effect. These operations narratives should be found in a specification hardware set as well as in the submitted hardware set. This is the way that the owner can tell that they're getting what they want. This is the way the architect can confirm that all of the hardware that is being supplied is compatible and will work within the system. And it also protects you. If you're providing some kind of wander guard system and you get this approved and you wire it up and install it and everything is working the way that the operations narrative described it, and then the owner changes their mind, now it's much easier to get a change order because you've already said, this is how it's going to be wired. This is the description of how this whole opening works. So whether you're working with somebody else's operations narrative or you're creating your own, it is critical that these items are listed. So here's an example of a pretty typical opening. Door normally closed, latched, and secure at all times. Presenting a valid key code will unlock the electric strike for 5 seconds. Mechanical key override at all times from the outside. During a power failure, the lock will remain secure. Red LED, the door is locked. Green LED, the door is unlocked. Free egress from inside at all times. That covers the bases, short, sweet, to the point. Everybody could wire this up if they needed to, and everybody could build a hardware set from this description based on knowing, okay, we've got an electric strike, it's going to be fail secure, we're going to have mechanical key override, so I'll use a storeroom function lock set, and you can build the hardware set based on this description. The electrified hardware, this is the hardware list just for the electrified hardware components. If you were supplying the entire opening, you would put it in DHI format, hang the door, secure the door, control the door, protect the door. But in this case, they're just listing the components for the electrified hardware. You could also turn it into an elevation drawing showing the location of the keypad, the electric strike, your incoming power, your power supply. And then from there, somebody can build a wiring diagram that's point to point, the actual system wiring diagram from the power supply, which exact relays that we're using and where. On the door schedule, they list the location and the door number, and then the size, the weight, the height, and the width of the door. The door type, does it have glass in it? What does it look like? The material, wood, hollow metal, and what's the elevation of each? Then it gets into jam details and other details. The set towards the end, the column towards the end, hardware set. The hardware set number should be listed in the door schedule, and any special notes, card reader, STC 30, those kind of things would be in the remarks column. You will see those types of things on assisted living projects where they've got the wander guard or any kind of card reader or delayed egress. They'll have notes in the remarks column on the door schedule. Let's get a closer look. So again, just the floor, what level that it's on, the door number, the size, the type of door, and then the last column will be your hardware set. You can pick up your frame information. Is it a 3-sided frame? Is it a side light frame? If it's a side light frame, that may change where you have to bring wires, especially if they get quite large. Your door elevations, flush doors are really easy to put hardware on because there's no limitations. But if you get a glass kit that comes down in here and you've got an exit device that goes across, do you need a shim kit? What type of style do you have? Do you have enough width for a full mortise lock, or does it have to be a narrow style mortise lock? Exit device, vertical rod, do I have enough room on that door? Those are kinds of things you need to know. What is the door elevation? And then the hardware set, as I mentioned, will be the last column on the door schedule. It'll give you the set number, and then from there you go to the spec book and look at part 3, the very final part. It lists all the hardware items for those doors. And if this happened to be one that had access control or delayed egress or controlled egress with the wander guard, then we would put the operations narrative right